The goal of this video is to help you understand the idea behind the distributive property. But before we talk about the distributive property, we're going to review the idea behind multiplication. One of the ways we think about multiplication is by thinking about having identical groups of objects. In this picture, we have 5 bags that each contain 4 apples. How many apples are there? We have 5 groups of 4, so we compute 5 times 4 to get 20. I'm going to write this again with the word apples in the equation to help us keep track of the object that we're talking about. This is important because in the upcoming pictures we'll have multiple types of objects. The distributive property is just an extension of this idea, where we have many types of objects in the groups. In this picture, we have 4 bags that each contain 3 apples and 2 pears. How many of each type of fruit do we have? It makes sense to count the fruits separately. Let's start with the apples. We have 4 groups of 3 apples, which means we have 4 times 3 apples, or 12 apples. Now let's look at the pears. We have 4 groups of 2 pears, which means we have 4 times 2 pears, or 8 pears. The idea of looking at each object separately is the foundation of the distributive property. Mathematically, we could write it like this. 4 times 3 apples plus 2 pears is equal to 4 times 3 apples plus 4 times 2 pears. In other words, this says that if we have 4 groups of 3 apples and 2 pears, then we have the same thing as 4 groups of 3 apples and 4 groups of 2 pears. It doesn't matter what types of objects we have, as long as the groups are the same, the distributive property will work. Here we have 3 groups of 2 dimes and 3 pennies. How much money do we have? 3 times 2 dimes plus 3 pennies is the same as 3 times 2 dimes plus 3 times 3 pennies, which is 6 dimes and 9 pennies. How much money is that? Dimes are worth 10 cents each, so 6 dimes is worth 60 cents. Pennies are worth 1 cent each, so 9 pennies is worth 9 cents. 60 cents plus 9 cents is 69 cents. We can even do it with groups of blocks. These are pictures of base 10 blocks so that the long sticks are made out of 10 squares. We have 3 groups of 2 sticks and 3 squares. 3 times 2 sticks plus 3 squares is equal to 3 times 2 sticks plus 3 times 3 squares, which is 6 sticks and 9 squares. What do 6 sticks and 9 squares represent? 6 tens and 9 ones, or 69. These examples show us the general pattern for the distributive property. In each case, we're counting up objects when we had groups containing multiple types of objects. In the first example, we looked at bags of fruit. We had 4 groups containing 3 apples and 2 pears, which we wrote as 4 times 3 apples plus 2 pears is equal to 4 times 3 apples plus 4 times 2 pears. In the second example, we looked at money. We had 3 groups containing 2 dimes and 3 pennies, which we wrote as 3 times 2 dimes plus 3 pennies equals 3 times 2 dimes plus 3 times 3 pennies. And in the third example, we looked at base 10 blocks. We had 3 groups containing 2 sticks and 3 squares, which we wrote as 3 times 2 sticks plus 3 squares is equal to 3 times 2 sticks plus 3 times 3 squares. As we can see, the distributive property is just a way of counting objects and organizing information.